frequency of compounding. In the previous module, we used these two formulas to calculate the future value and the present value of a single cash flow. We used these formulas to calculate present and future values using annual interest rates and investments for a given number of years. However, the variables R and N in these formulas do not reflect annual values. The R in these formulas represents the interest rate per compounding period, and the N represents the number of compounding periods. The compounding period tells us how many times over the course of a year interest compounds. In other words, how often interest is calculated on the amount of money in an account and then added into the account. Sometimes this happens once a year, in which case the calculations we did in the previous module would be correct, but interest usually compounds more than once a year. For example, interest could compound semi-annually, which means twice a year, quarterly, which means 4 times a year, monthly, 12 times a year, fortnightly, 26 times a year. A fortnight is 2 weeks, so there's slightly more than 26 fortnights in a year, but that's the number that we use. Similarly, there are slightly more than 52 weeks in a year, but we use the number 52 for weekly compounding. And finally, daily compounding is taken to mean 365 times a year. Leap years are ignored. In order to calculate R in the present value and future value formulas, we need to divide the annual interest rate by the number of compounding periods per year. And to calculate N in those formulas, we need to multiply the number of years by the number of compounding periods per year. Let's do an example to illustrate the effect of compounding more frequently than once a year. What is the future value of $1,000 invested for 4 years at an interest rate of 8% per annum, compounding semi-annually? Before we can use the formulas, we need to calculate the R and the N given semi-annual compounding. The annual interest rate of 8% is divided by 2 for semi-annual compounding, so the interest rate per compounding period for each period of 6 months is 4%. And the number of compounding periods is the number of years 4 times the number of compounding periods per year. Now that we have R equals 4% and N equals 8, we can put them into our formula for the future value of a single cash flow, and the answer is $1,368.57. This example is essentially the same one that we used in the previous module, but with annual compounding, the future value was $1,360. Because interest is calculated and added into the account more often, the compounding effect of interest on interest is greater, and therefore the future value is slightly greater. Let's do another example, this time based on the second example that we did in the previous module. What is the present value of $4,000 to be received in 7 years if the interest rate is 5% per annum, compounded quarterly? Once again, we need to calculate the interest rate per compounding period and the number of periods given quarterly compounding. The interest rate per compounding period is 1.25%, and the number of periods is 28. Now that we have C equal to 4,000, R equal to 1.25% or 0.0125 in the formula, and N equal to 28, what is the present value? The answer is $2,824.87. When we did this example with annual compounding in the previous module, The answer was $2,843. In the previous example in this module, compounding more than once a year increased the future value. We can see here that compounding more than once a year decreases the present value. The reason for this is that the present value represents the amount that we would have to deposit into a bank account in order for it to grow to the future value. With annual compounding, we have to deposit $2,843 in order to grow to $4,000. Because we get more interest on interest with quarterly compounding, we only have to deposit $2,825 to achieve a balance of $4,000 in 7 years.